Hi, we're going to be learning about point-slope formula and point-slope form of an equation today. And the main idea is that if you are given any 2 points, you can write the equation of the line containing those points using the slope formula. We're actually going to call it the point-slope form of an equation, but I'm going to show you in a second here how it's just the slope formula rearranged. So as you can see here, if I know the slope and I know 1 point, then I've got an x and a y and I can write an equation, and you'll see how that works in just a minute. Okay, here we go. We're given the slope of 2/3 and a point on a line, which is 3/6. We're going to start with this type of a problem, and we'll start with our point-slope equation, which is y minus y1 equals m parentheses x minus x1. And you'll get really familiar with this. So now I'm going to substitute in what I know, and I end up with y minus, and my y1 is 6, equals, my slope is 2/3, parentheses x minus x1 is 3. Okay, so now I need to do a little distributive property between the 2/3 and the x and the -3, and I get y minus 6 equals 2/3 x minus 2/3 times 3. Okay, and now I'm just going to simplify. I'm going to cancel out the 3's, and I get y minus 6 equals 2/3 x minus 2. I'm trying to get this into slope-intercept form. In order to do that, I've got one more step. I've got to add 6 to both sides. Add 6, and I end up with y equals 2/3 x plus 4. And that's a form that you're familiar with. That's slope-intercept form. So we used a point-slope form. This up here is the point-slope form of the equation to help us write an equation in slope-intercept form. Let's try it again, this time using 2 points instead of the slope and 1 point. Okay, so I have 2 points. I'm going to label them x1 and y1 and x2 and y2. Good place to start always with your 2 points is to label them. And the first thing I'm going to start off with is my slope formula, because I can't write the equation without knowing the slope. So I've got m equals y2 minus y1 over x2 minus x1. I think it's always helpful to write out the formula first so you don't mess up your numbers. And I end up with 2 minus a -4 all over 3 minus 1. I can turn this into plus a positive. I get 6 over 2 equals 3. So my slope, m, equals 3. Now I get to choose just 1 point, doesn't matter which one. I get to choose 1 point to put into my point-slope formula. So I'm going to choose the one without any negatives. I'm going to choose my 3, 2. So I go ahead and write it out, y minus, in this case I'm using y2, so 2, equals, equals my slope, m, which is 3, x minus, and then my x2, which is 3. Okay, so the things that I put in here were my y2. I plugged that in for my y value, and then 3, which is my slope, and then 3, which is up here, which is my x value. Now I go ahead and simplify. I get y minus 2 equals, I want to make sure I draw my arrows, 3x minus 9. And again, I need to put into slope-intercept form, so I add 2, and I get y equals 3x minus 7. Now this is in slope-intercept form, and I can graph from this form. Okay, we're going to try one more really quick here. Let's label our points: x1, y1, x2, and y2. And I'm going to go ahead and first figure out my slope. That's the first step. So m equals y2 minus y1, which is negative 3 minus negative 4, and x2 minus x1, which is 5 minus 0. My slope is, turn this into a big plus, negative 3 plus 4 is 1 over 5. Okay, now I'm going to go ahead and put my slope in and 1 point in. I can pick either point. Since this one has 0, I think I will pick it because it seems like it will be easier. So I have y minus y1 is negative 4. Be sure that you have the minus and the negative, equals 1/5 x minus x1 in this case is 0. That's nice and easy. I end up with y plus 4 equals 1/5 x, since 1/5 times 0 is 0. And I go ahead and subtract 4, and my final linear equation in slope-intercept form is y equals 1/5 x minus 4.